In this video, we're going to take a look at solving this equation. We have the quantity of x minus 5 times the quantity of x minus 1 equals 0. And the first thing that I want to point out, very important, is that we have this right-hand side set equal to 0. In some future problems, you are going to have this side of the equation where it's some other value other than 0. And what you need to understand is that when you're using the zero product property to solve polynomial equations, it is essential that your right-hand side or one of your sides of your equation is equal to 0. So we already have that here, so that's good. And then the second key idea when you're going to apply the zero product property is that you have to have a product over here. You have to have something times something else. Or in other words, this left-hand side of the equation has to be factored. This is a factor, this is a factor. You have two factors multiplied together to get 0. Whenever you have that set up, that's when you know you can use the zero product property. All right, so let's actually work that out. So the zero product property states that if I'm multiplying two factors and getting 0, there's only two possible ways that can happen. Possibility number one is that this first factor is equal to 0. So we want to know, when does x minus 5 equal to 0? Possibility number two, when does x minus 1 equal 0? So whenever this factor is 0, that's going to work out as a solution, or this first factor, when that's equal to 0. To solve these, x minus 5 equals 0, you just add 5 to both sides. So we know that when x equals 5, that is a good solution to this equation. And notice if I substitute that number in for x here, this equation would become 5 minus 5 times, we're plugging in 5 for x, so this would be 5 minus 1. And if we simplify, 5 minus 5 is 0, 5 minus 1 is 4, and 0 times 4 is in fact equal to 0. So we know this is definitely a good solution. Let's take a look at this part. If x minus 1 equals 0, we add 1 to both sides, we get x equals 1. So my second solution, I'm thinking, is x equals 1. Let's plug it in and see if that math works out. So if x equals 1, this would be 1 minus 5. And we're going to multiply by, plug in 1 right here. This would be 1 minus 1. And if we simplify, 1 minus 5 is negative 4, 1 minus 1 is 0, and negative 4 times 0 is 0. So we have a good solution here. So our two solutions are x equals 5, x equals 1. Now, before I leave this video, I want to point out one thing for just hey, this is what's going to happen in the future. In the future, when you look at an equation like this, you might not have it written in factored form. And we learned, and this is actually good review for a previous lesson, we learned in a previous lesson that if I want to do x minus 5 times x minus 1, if I want to multiply this out and rewrite this expression, I have a process that I can follow called FOIL. Or you can think of it as the distributive property twice. I'm going to distribute this x, I'm going to distribute this negative 5, and I'm going to have a new expression here that is equivalent to this expression, but just looks a little bit different. So x times x is x squared. X times, so we took care of this part of FOIL. X times negative 1 would be minus x. Negative 5 times x would be negative 5x. And negative 5 times negative 1 would be plus 5. I can combine like terms here. This could be thought of as x squared minus 6x plus 5. So this expression, this x minus 5 times the quantity x minus 1, is equivalent to this expression, x squared minus 6x plus 5. And what that means is that for any number that I pick for x, this should give me the same answer as what I get here when I evaluate the expression at that value of x. So let's try that real quick and just see it happen. So I can pick any number I want for x. Let's pick x equals 7. And let's see what this expression evaluates to when x equals 7. And let's see what this second expression evaluates to when x equals 7. And if all of our math is good here, we should get the same exact number. So when x equals 7, this would be 7 minus 5. This would be 7 minus 1. And then I can simplify this. 7 minus 5 is 2, 7 minus 1 is 6, and 2 times 6 is 12. And going a little bit further, that shows why I didn't have 7 as a solution to this original equation here. I don't want these two multiplied together to give me 12. I want these two quantities multiplied together to give me 0. So x equals 7 is not a solution to my original problem here, but it is what this expression would evaluate to for an x value of 7. Now, let's plug in the 7 into this expression. So this would be 7 squared minus 6 times 7 plus 5. And when we simplify an expression, we always follow the order of operations. So we take care of our exponent first. So 7 squared would just be 7 times 7, or 49. And then we take care of any multiplication that we might have. So in that case, we have the 6 times 7, which would be 42. And now we can just work this out from left to right. 49 minus 42 is 7, and 7 plus 5 is 12. So the whole point of that little exercise is to show that, hey, this expression right here is equivalent to this expression. And the reason that I'm bringing this up is because this problem in a future lesson is going to look much different. Instead of looking at it as the quantity of x minus 5 times the quantity of x minus 1 equals 0, you're going to see it as x squared minus 6x plus 5 equals 0. And although that is not our main goal at this moment, I just want to give you a heads up that this is where we're headed. We're going to have an equation that looks exactly like this, and the way that we're going to solve it is we're going to have to rewrite this left-hand side as a product. And that involves knowing how to factor. So in a future lesson, we're going to look at how do you factor x squared minus 6x plus 5.